Hi everyone, and welcome! This is Tsul, and today I'm going to show you how I've used neural networks to teach an AI how to play a game. I had some experience with machine learning in the past, but I had no experience with neural networks at all. So I had a general idea of what neural networks are and what they are capable of, but I didn't know how to actually implement them. So, in order to start somewhere, I went online and found a great book by Michael Nielsen called Neural Networks and Deep Learning. It's a free online book, and I'll link it in the description below. This book helped me understand neural networks' theoretical side, as well as a practical side, as it contains a lot of code examples and some great explanations on the subject. Another great video series that helped me is the 3 Blue 1 Brown Neural Networks playlist, as it contains a set of examples and explains the very basics of neural networks. And of course, a few good towards data science articles, which I will link in the description below. If you got this far, I'm assuming you know what neural networks are. I won't go into the specifics, and I will try to keep the video clear and light for those who don't understand them thoroughly. So, let's start. As you know, there are several ways to make a neural network learn. The most familiar one is backpropagation, but another way is by using a genetic algorithm, meaning I'm combining my neural network with evolution. How it works is this. Instead of creating just one neural network and correcting its weights and biases, like in the backpropagation algorithm, I've created a population of many networks. I made them randomly choose an action based on their current weights and biases, and after a time, I choose the best networks out of them by giving them a fitness score. Meaning, I chose the network with the best fitness out of all of the network's population. After that, I've disposed half of the networks, sorted by fitness, which means I've cut out the worst networks, and then copied the best network instead of those I've disposed of, and mutated those new networks I've just copied. So, to sum it up, instead of changing the weights and biases each time the network receives an input, a random mutation changes those weights and biases, and then I choose the best mutation and let it evolve further. So, let's get to it. This is Bob, and the network will be his brain. Bob wants to get to the end of this level, and I will help him by making his brain learn how to finish this level. For the first try, the network, or Bob's brain, had 2 inputs, distance to the next bit and grounded, which means that Bob can see the next bit and can also sense whether he's on ground or not. His brain also had 1 output, should I jump now or not? Let's see how it went. On the upper left side of the screen, you can see which generation is currently running, what's the population size, and how many Bobs are still alive. Oh, another thing. Bob has no control over which direction he should go. He just goes right. As you can see, Bob learned to jump on the 4th generation, a bit slow for such a simple network, so I thought to myself, maybe I'll try giving Bob some free will, and expanded his network. Now, Bob has the ability to choose which direction he should go, left or right, and also when to jump. So basically, our network is the same, only I've added another output. Let's see how it went. Okay, what? I gave him free will and he chose not to use it? Why? Well, at this point, I was a bit stumped. So I gave it another go. This time, I've waited a bit longer to see what will happen. Oh, also, I've added a timer, which indicates the time to live of each Bob. Also, I put the scores up, so we can see which was the best Bob and which was the worst Bob. So, what happened? They barely moved, yet a mutation made one of the Bobs skip. And in the next generation, another one skipped. They were telling me something. They were telling me there's a bug in my code. The output was fine, but I forgot to multiply the output of the network with speed. Meaning they were just super slow, and they barely moved each time. So I fixed the bug and went on to give it another try. I've also changed the network a bit. Now, I've added another input, so Bob can also see if there's a platform directly below him. So currently, our network has 3 inputs, the next bit, grounded, and a site for the next platform Bob will land on, and 2 outputs, direction, which is a number between 1 and -1, which also determines the speed, and also jump. Let's see how it went.
Reboot, I'm cold red, my service automated, like data running through my veins. Got you distracted, subconscious overloaded. Careful, don't pull the cord on me. No time to stay around. Keep walking till you get out of my face. Regrets, restricted access. I'm used to fly to get up here. We love discharging. I can't waste my time with someone slowing me down. So high, I'm floating. I'm shining in my prime. Start rolling over 'cause you can't take my crown. I'll always be 10 feet off the ground. My crown. I'll always be 10 feet off the ground. Can't take my crown. Can't take my crown. Can't take my crown. Rewind my circuits, but you don't get that courage, 'cause you can handle my game. No, my drive's a puzzle. I got you so bumfuzzled, 'cause you can fall into my pain. No time to stay around. Keep walking till you get out of.
In 24 generations, Bob finished the level. The work was not done though, and I wanted to do better. So I changed the fitness a bit and calculated it more accurately. Now, Bob manages to learn how to finish the level in 10 generations. We did it! In 9 generations, Bob actually learned how to play the game. Now, let's see how Bob and his new brain take on a different level. Well, as you can see, Bob's brain can actually handle similar levels easily now. So, thanks you for watching. I hope you enjoyed. If you'd like to see more and would like me to publish a full tutorial for this project, be sure to comment me and I promise I'll find the time to do so. See you in my next project.